Hi again, everyone. I hope you're doing okay. So, we're going to continue from where we left in the previous class. And as we can see, the last class we did a bit switch, we also did a bit inverter and a byte OR. We saw that we are able to get get a byte, which is 8 bits, and another byte which is another 8 bits, and we are able to OR them as we did over here. And then using the byte maker, take the bits, this is the splitter, split, pair them and OR them, then um, uh, take the output bits and um, uh, create a bit from that using this 8-bit maker and output the bytes. And for today, we are going to continue byte not. This is byte not, which should be the same as this, and the other level is adding bytes. So let's start with byte not. The level says our previous model of brain size being the main predictor of intelligence was naive. Okay. Tool making and usage is a key in the early evolutionary stage of development of developing intelligence. Okay. Therefore, the number of arms on a creature is clearly the main predictor of intelligence. Did you know there is a sea of creatures from your planet with 4 times as many arms as you, and they are doing better in tests? Okay. Note each bit of the byte input. This should be easy. To note each bit, first we get a byte and we have a byte output. So we know for the first thing we need to take the byte and split it into bits, and then clearly just use this not yet to, let me just duplicate it, 2 3 4 5 4 5 6 7 and finally 8. Now we have 8 bits and we're told we should note them, and we do note them like negating, and then after that we convert it back to a byte, which we use the byte maker, which you can just connect over here and maybe move this a bit for symmetry and wire everything up again. That's about it. Our inputs are off. We get on inputs and you can just use any number here, and we get the not, the inverse of it, which I assume it should be the negative number, but I'm not really sure as per now. But we'll see how we are able to utilize this not get on a byte to perform something. I don't know if it's, yeah, I think it's the complement. Okay. Which is also used in addition of negative numbers, but we'll see. and we can test everything. And now we have unlocked the 8-bit notes. This is texting. This, as you can see, it's kind of different from the other one. These big circles are they indicate that this is a byte. This one deals with bytes, which is 8 bits, not a single bit. Negation. So node. The next one is adding bytes. So how do we add bytes? And let's see. Adding the two inputs. Add the two input bytes. Each output a bit, and the output should be a result. Each output bit in the output should be a result of the addition of the corresponding bits from the input and potential carry. So, okay. If the result does not fit the 8-bit, turn the output carry green. You can think of it as a 9th bit. Finally, there is an input carry as well. This is useful for chaining together byte address adders to larger numbers. You can think of this carry as adding either 0 or 1. It's the hint if you get stuck. Okay, so we are told, we have 2 bytes, and we have this. We're told we have to add this byte. So as we know, we had an adder over here. This is a full adder, but we have a byte and a byte. But the adder we had was meant for bits. So again, let me read the instruction. Add the 2 bytes input. Each output bit in the output should be a result of adding the 2 input bytes. Each output bit in the output should be a result of addition of corresponding bits from the input and a potential carry. Okay, so since we don't have any bits, and the adder that we have here was meant to work with bits, then that tells us that we need to do a split. Yeah, so we'll just take the bytes, split it, take this other byte, let's do a 12 over here and a 56, 6, and let's add So to add, we have to add, I think, the corresponding bits. So the first one, no, that's not gonna work. Let's try chaining. I think how many bits? One, two, three, 4, 5, 6, 7, and an eighth adder. So the adder adds 2 bits. So let's pick up the first bit and the other pair of bits, and the next one, and if this gives us anything, yeah, okay, that's the first one, and then we have to chain them. Now I remember how we're supposed to do it. Okay, but if we have an okay, the output over here is either 1 or 0, since it's just a bit. But then if one of these is on, get an on. And if this is on and this is on, then that's 1 and 1, which is 1, 0, which means we get a 1. Let me see. We will start with 0, 0, then 0, 1, then 1, 0, then 1, 1. That means that the first one will be 0, 0, this as 0 and 0 as it is. Then our result is 0, 0. Yeah. And if we have 1, let's just have a 0 over here and a 1 over here. That means that our output is 1 and carry is that. So we have 0, 0, 1. And if we invert and have this as 0 and this as 1, we should still have the same thing. So it should be 0, 1. So reading from the bottom, 0, 1. And only if both of them are 1 is when we get 1, 1. We get a carry. Okay. Then the carry should be chained over to the next one and move to the next, which is this 2 and the second byte bit, I mean. And then the carry is carried over to the next, and the next one is this, but we somehow need to arrange this properly. And now the fourth one, fourth one goes here, and the next fourth one goes in here, and the carry is chained to the next adder. The eighth one is brought over here, and the eighth one also put up here. The carry is carried over to the next, and 16 is taken over, and we also have another 16, and the carry is chained over. The next one is 32, which is also brought down and used here, and the next 32 used here, the carry carried over to the next bit, 64 as well brought over, 64, the next 64, and the carry carried over, and finally the 128 bit. And now we have 8 bits of carry. Now this final bit does not go anywhere, but then the thing that kind of is not clear is what this is for. I assume it should go here, but I'm not really sure if okay, by doing that, now we have a byte output and bits, so we can take the carry can now be brought over and the byte we should use a byte maker to build this byte. Now we can connect these bits over to form a byte. uh, yeah, I prefer the right angled right angles. This is much cleaner. And finally the last bit. And the only thing that I'm not sure where it should go is this, but let me just plug it here and see what happens. So this is our final circuit for adding bytes. So we'll just test and everything. And yeah, turns out that's how we're supposed to do. So this circuit is able to take 2 bytes and split it into bits, and using this chain of 3-bit adders, add them together and give out the carry and build up the last bit, a byte from this bit within the adders. This is what I'm not sure of what it does, so if you know what it is able to do, please let me know in the comment why this works. But yeah, I think that is enough, should be enough for today, and see you in the next class. Bye.